Here we are in Mississauga, Ontario, looking at a company called Drystill. One of the biggest costs in our manufacturing of ethanol is actually the distillation process. Drystill, as the name would suggest, has found a method to significantly reduce the costs of distillation. That comes to the bottom line of our companies, but more importantly, we save a whole bunch of energy as well. But ultimately, it's savings to the company, less energy, and better for the environment.
Drystill is essentially a startup company which has invented a new chemical separation technology. This technology does chemical separations at low temperature and with low energy. Most people don't know it, but distillation accounts for something like 5% of all the energy that is used in the United States. Our technology is low energy use and would, in certain processes, reduce energy consumption by 50%. Our technology is based on thermally integrated evaporation and gas absorption technology. At the heart of our technology is this particular piece of equipment up there, which we call a SAM, or stripper absorption module.
Well, our process is unique because whereas distillation has a high temperature boiling and a low temperature condensing, we reverse that. We've got a low temperature boiling and a high temperature absorption. We take water out of our feed material and put it into a brine. That's stage one. Then we take the brine and we boil it. We can choose our conditions for boiling it. We can use multiple effect, we can use high temperatures, and not affect at all what our original feed material. What's unique about this technology is we're using heat pipes, and they take the heat of absorption, move it across over to the evaporator section, and that's how the evaporation takes place. There is no externally applied heat to that. With this technology, we hope that we'll be able to drive off the water at a very low temperature and with very low energy, and then shift our attention to what's left over and try and get the best out of what's left. In the ethanol production industry, there is no technology right now that will take out the ethanol as it's being produced in the fermentation and still leave the yeast living. Anything can be done, but it's just not economical with the technologies that we have presently. This technology is one that will make that feasible. It can distill a brew at 30 degrees Celsius, and the bugs will live. And then it can distill it over again. It can distill it without harming the bugs, and the bugs can live on to the next batch. For instance, if it's a batch process, more likely it would be a continuous process, and the bugs would go right through to the end. In the cellulosic industry, this is even more important because the temperatures used in distillation often destroy the most expensive component of it, which is the enzymes. If we do the distillation at low temperature, we can save the enzyme, potentially recycle some of those enzymes and reduce the cost. So this is an indirect environmental benefit.
So basically it's modular. We just add more heat pipes. The more boiling and distillation you want to do, you got to add more heat pipes. And heat pipes can be designed in all different kinds of configurations. There's different advantages to different types of heat pipes, and they can be arranged in SAMs in so many different ways. The great thing about the design of this is the flexibility. It can be designed to meet any kind of application.
We are very fortunate in our development so far to be located at Fielding. In this way, we've been able to do things and reduce our costs to the point where we can progress forward without raising additional capital. Initially, we would like to sell our technology in Canada and the United States, but later we see the technology being rolled out internationally.